Welcome to our session on external identities. I'm Jazz and I'm a program manager on the Azure AD B2C engineering team. Today we are going to cover all of the latest features that have been released onto the Azure AD B2C platform. We're going to show you the new auth options that include logging in with your phone or an Apple ID, how identity protection can protect your users' accounts, adding business logic and flexibility with API connectors, and using your own custom domain name for the login endpoint. Some notable mentions, which we don't have a demo for today, but are things that we've had a lot of requests for. We now have support to embed the B2C login pages into an iframe. You can now reset B2C users' passwords through the Azure portal, and we are bringing 4 nines of availability to Azure AD B2C.
Hi, my name is Christer Jung. I'm also a program manager in identity engineering. I'm based in Stockholm in Sweden. Phone sign-in and sign-up is available for B2C user flows. You may want to use phone sign-in in your apps if your user sees it as the most natural way to sign in or when users just don't want to remember their emails. In order to start using phone sign-in and sign-up in your apps, you first need to configure the option on the local account identity provider to use phone sign-in. Then you need to add it as an option in your user flow configuration. And when you do that, one thing to consider is if you should enable or disable the setting of using email as an option for account recovery. Enabling this will ask the user for an email and will verify it during the sign-up process. Disabling will not. Signing in with Apple ID has been a frequently asked feature from B2C, and it's now available in user flows. You start with the Apple Developer Portal, where you register an app and you specify details of your app name, your redirect URI, etc. that B2C needs. This is very much the same as for other social providers when you do identity federation. What is unique in Apple's case is that you export a P8 file with a key that acts like the client security. Then in the Azure portal, you configure the Apple as an identity provider. You specify the Apple specific details like the team ID, the service ID, and then you drag and drop the P8 file up to the portal and add your client secret. This secret needs to be rotated every 180 days, and for that purpose, we've added a button that says Renew Secret, so you can do that as easy as possible. But first, we need to understand a little bit more about how decentralized identities works. You have 3 actors. You have the issuer, you have the holder, and you have the verifier. In this slide, you see Woodgrove act as the issuer, and Woodgrove is in complete control over how credentials should be issued, how that process looks like, and what claims and credentials it should include. But when verifiable credentials is issued to the user, the public key of that credential is in the new VC is written to blockchain as evidence of the issuance. So someone wanting to check that it's actually you can go to blockchain and verify the public key. Woodgrove's public key is also on blockchain, so you can verify that Woodgrove actually was the issuer. On the phone, then, the user has the verifiable credential as a card in Microsoft Authenticator app. In places where the VC is accepted, the user may choose to use it. Fabricam in this case happened to have an online service that accepts this type of verifiable credentials and makes presentation requests to the user to provide them. The user decides to accept such a request, makes a signed presentation response to Fabricam, and so that Fabricam can validate via finding the public key on blockchain. Microsoft has released a new product into preview early April that is called Azure AD Verifiable Credentials for this. How do you combine Azure AD B2C with verifiable credentials? Here we have a diagram where shows you how you can provide a solution where B2C acts as an identity provider but accepts verifiable credentials as a new way of signing in. For that, it gets support from a VC Verifier API. Step 1 is that the app makes an auth request to B2C, where B2C's policy responds with a web page, and upon loading that web page in the browser, it contacts the VC Verifier API. Step 2 is that the browser gets information from the VC Verifier API that it translates into a QR code and displays it, plus a session ID. Step number 3 is that me as a user, I pull up my Microsoft Authenticator app and I scan the QR code and get a presentation request from the app. If the user chooses to allow it, press the allow button. That means that the authenticator posts a signed version of the verifiable credentials to the API, who can validate it using blockchain, etc., via Microsoft's SDKs and API. It checks that the public key is correct and that you can validate the signed request from the authenticator app. In step number 5, the browser sees that the validation has happened and signals that it's time to continue the B2C user journey. And then step number 6, B2C's policy checks with the verifier API to see what really happened, if who was validated, and the status of it. And based on that, in step number 7, B2C can return a token to the application who can continue. So now it's time for demonstrations of this. So time for demonstrations. Phone sign-in. So what you need to do first is find your identity provider for local accounts and enable phone sign-in, because if you don't, it will not be available. So find your local account identity provider, make sure to check the checkbox for phone and click save so you have it. Then you go to user flows, and when you create a new user flow, you can pick sign up and sign in, you pick recommended and you create it, you give it a name. Oops, spelling like this. And if you check the one in the previous screen, you will have phone sign up as an option. So let's check that one. And let's click create. Once you have this user flow, the policy, and you go into it, in properties, you will have this, in properties, you have this email recovery option that I mentioned if you want to enable or disable account recovery via email. I'm going to switch it off just to make a change. So when that has saved, we're able to start using the policy, execute it, and the user might sign in with phone number or not. So I can type a phone number and continue, and you will get directed to the standard way of doing phone challenge in the B2C policies. The second thing was Apple sign up. So if we go back to identity providers, or back out of the policy and to identity providers, you will see that we have in the list Apple. And if you go into Apple, you have a few configurations, and as I mentioned, you have the few items that you specified in the Apple Developer Portal, like the Team ID, Client ID, and the Key ID. Then you have a box down here that you can drag and drop the key up to and just save it. So it's super easy to get the Apple key, the P8 key going. Then when you have a user flow, a policy, if you added and configured Apple, you will have it available and you can just check it. So when you run it, you will have another claims provider with Apple ID down below. And clicking on that will take you to the standard sign-in procedure with Apple ID, where you specify an account and you get to verify it on your Mac or iPhone, etc. So the third option was B2C with verifiable credentials. So let's start the authenticator and do some screen sharing here so you can see it all in action. On the left-hand side, I'm mirroring my iPhone, and on the right-hand side, we have a web app. And if you remember from the slides, you need to issue a credential first. So the first step here is to give myself a credential. Although I have a couple of verifiable credentials already in my authenticator, I need the special one here to use this application. So I'm making a request to the issuer to say I need verifiable credentials. It produces a QR code. Up in the upper right corner, there's a scan button in the authenticator. I'm going to click it now. I'm going to point it over, and Authenticator reads it and tells me that the way I can get a card here is to go to this B2C identity provider, prove that it's really me with my account. So let's do that now. And with those, oh, of course, this works better, I hope. Yes, thank you. And I get the option to cancel out if I don't want it, if I change my mind, but I do need this card because I want to sign in. So I'm going to accept it and say add it to my wallet. And I do have this new build 2021 card. So how can I use this one? If I go to an application that is protected by B2C and I have a sign-in policy, if I configure it together with the VC Verifier API and add it as a claims provider, I can get another way of signing in with verifiable credentials. I'm going to click that one. And here we're talking to the Verifier API and we get the information to produce the QR code. Again, up in the right corner, I'm going to click on scanning it. And I'm going to scan the QR code. You can see that in the presentation request comes from the app Build 2021 B2C Verifier. It's asking for my membership card and do I want to present it or not. I think this is a good idea, so I say yes, I allow it. I'll share it with the B2C app, the verifier. It does the validation to see it was really issued, that the keys matches in blockchain, etc. It continues and B2C signs me in, and I have a token issued by B2C. And in a real app, I would be able to continue to do whatever I do. So that was the demo. On to the next slide.
Let's now take a look at identity protection and conditional access. I'm going to walk you through the benefits of using it and how quickly you can get it set up and working. Identity protection uses signals to determine the risk of the user logging in. We can determine the risk of a user through many signals, such as known bad IP addresses, password spray behavior, or atypical travel, and other things. We accumulate signals from Azure AD, Azure AD B2C, and Microsoft account platforms to create a holistic picture of the risks involved. Once we understand the risk of the user, we can act to protect the account with conditional access. The risk-based authentication control allows us to help prevent your accounts and their data from being compromised by bad actors. When a risky user is detected, conditional access can be enforced to add an additional challenge for the user to prove they really are who they say they are. This can be enforced using multi-factor authentication, or you can just block the user access entirely. To set it up, we need to do a couple of things. We need to enable the P2 license for your Azure AD B2C tenant, then create a conditional access policy which reacts to the risky user, and then finally, enable the user flow to evaluate conditional access policies. To enable your Azure AD B2C for the P2 license, go to the Azure portal and select your Azure AD directory where your Azure AD B2C resource lives. Then select your resource, and in the Overview tab, you will see a pricing tier. Click the link to the pricing tier, and you will see a pop-up where you can switch the license from P1 to P2. Then save your changes. Let's now create a conditional access policy which asks users to perform MFA if the identity protection engine flags the user as risky. Go to your Azure AD B2C directory in the Azure portal and select the Azure AD blade. Then click the security icon in the left pane. Then click the conditional access menu and click the new policy button to create a new conditional access policy. That's the screen you'll be seeing on the screen. A conditional access policy allows you to configure the scope to which it will be applied. That will be to particular users and apps. It allows you to configure which conditions will trigger a challenge, and then finally how you'd like to grant users through a particular challenge if a condition is met. In this example, I've selected one user to be in scope for this policy and one single application. This is fine for testing, but in the real world, you'll probably want to select all users and then exclude all of your admin accounts so that only your B2C users are impacted by conditional access when accessing your B2C applications. Next, we need to configure the conditions on which this policy will trigger a challenge. The identity protection-based controls are listed as user risk and sign-in risk. User risk represents the probability that a given identity or account is compromised, and sign-in risk represents the probability that a given authentication request isn't authorized by the identity owner. We allow you to set values between low, and high. And to work out the exact level that is suitable for your business, the conditional access policy can be run in report mode, whilst you understand the added friction the various risk levels will create to the user experience. Once you analyze the report, it will be clearer as to which risk level would be best applied to trigger the conditional access policy. Here, I've selected high, medium, and low for user risk and high and medium for sign-in risk, and then I'm going to save the selections. Under grant, we choose how the user can remediate the risk in the case where the identity protection engine has met the user risk or the sign-in risk that we set prior. The user can be asked to perform multi-factor authentication or reset their password. We could also prevent access entirely by selecting block access. Finally, you can either set the policy to be enabled, disabled, or set to report-only mode. For the demo, we will enable this policy. Now that we have a conditional access policy, we can configure the user flow to evaluate it. This means any application that uses this user flow, where a conditional access policy has this application and user account in scope, would have the conditional access policy evaluate and provide a dynamic MFA prompt based on the user and sign-in risk. So find your user flow in the Azure AD B2C Blade, and then select Properties, select the MFA method, set MFA enforcement to conditional, and check the box for enforced conditional access policies. Now your user flow will evaluate all the conditional access policies set up in your directory, and of course, only be applied if the user and application are in scope. Everything is now set up, and we can test identity protection and conditional access. Here, the top video shows a user logging in through a normal browser, and you'll see that the user has no problem logging in with just a username and password. And below, we see a user logging in through the Tor browser, and now the same user with the same credentials is being challenged for multi-factor authentication. That's identity protection kicking in and doing its thing. Let's take a look at API connectors. These add more flexibility to your B2C user flows. API connectors allow you to call a REST API at particular points within a user flow, and these REST API endpoints can then be used to drive your own custom logic. For example, you may only want to allow users signing up to have a valid ID number, or you may only allow them to sign up if they come in from a specific domain name. That's what we're going to demo today. To do this, we need to do a couple of things. We need to create and host an API on a publicly accessible endpoint. We need to provide this endpoint to Azure AD B2C, and we need to configure our user flow to call the endpoint at the sign-up stage. We will configure this API for basic authentication today. Azure AD B2C supports both basic authentication and certificate-based authentication to communicate to your API endpoints today. To create an API, we can start by taking a sample from our doc site. You'll find lots of samples for .NET, Node.js, and Python. When Azure AD B2C signs up a user and makes a call to your REST API, it will post a JSON payload with all of the claims collected in the journey thus far. You can see in this JSON we have a key called email, which we can pass at the API to do our logic. I've taken the .NET sample today and then modified it slightly to take the email address and check the email address's domain name with a set of domain names that I'm looking for. So in this case, my API is only going to allow domain names from outlook.com or gmail.com. And then if we detect any other API, the API is going to send back a HTTP 409 error response with a friendly message in the body. The error message that we insert into the HTTP 409 error response, it will be displayed back to the user on the B2C sign-up screen. So once your API works locally, then you can host it to your favorite spot. Next, we need to tell Azure AD B2C that your endpoint exists. To add your endpoint, we can go to the Azure AD B2C Blade and then click API Connectors. Click New API Connector, give your API a name, provide your API's endpoint, and then fill in the basic authentication credentials. I've called mine block email domains. Your API connector is now available to any user flow, but for the API to get called, we must select a particular user flow and configure your API connector to be called. So find and select your user flow in the Azure AD B2C Blade, and then click the API connectors menu. Here you can see two options for the API to be called, either after sign in with a federated account or before creating the local user account. So in this case, we can select the block email domains API connector for both scenarios in this demo. We're all set up and ready to test this now. So go to your user flow and click the Run Now link. Click the Sign Up button and then try to sign up with an email that is at a domain name that is not outlook.com or gmail.com, and try to submit the form. You'll see that an error comes back and is presented to the user. That error is coming back from the API after it's evaluated the email address's domain name and determined that it is not from Outlook or gmail.com. If you try again with an email which is at Outlook or Gmail, then you'll be able to sign up successfully. Next, we'll take a look at custom domains with Guyan.
Thank you, Jazz. Let's look at the custom domains feature. There are multiple reasons why you may want to use the custom domains. Main one being the branding. In addition, you may want to use the new iframes feature we introduced, or you may want to have the cookie consistency between your B2C service and your application. Now let's look at how custom domains work. We use Azure Front Door to terminate your traffic coming into the custom domain name and forward that to B2C service. The SSL certificate that you'll be using to terminate the traffic can be either managed by Azure Front Door using a certificate issued by GGCert, or you can bring your own certificate and manage it inside the Key Vault. Let's look at the traffic flow for custom domains. You start by creating a CNAME record that forwards all the traffic for the custom domain to the Azure Front Door. Azure Front Door in turn forwards that traffic to the B2C service along with all the header and the source information of that request so that B2C can provide all the protection that it normally would provide. Okay, let's look at the process that you would follow to create a custom domain. You start by creating an Azure Front Door instance. The Azure Front Door instance is created using the portal by picking your subscription, the resource group that it should live in, and then by creating the front door front-end host that your CNAME will be getting forwarded to. Next, you will create the backend pool in Azure Front Door that identifies your B2C tenant and the host headers that will be forwarded with your request to the B2C service. Once you do that, you move on to creating the custom domain where you get the option of choosing to bring your own certificate or the Azure Manage certificate. If you pick the Front Door Manage certificate, there's an asynchronous process where a request will be made on behalf of you to GGCert to get that particular certificate issued. For this process to complete, you should already have the CNAME record that's created on your DNS. Now, few domains may have chosen to implement something called a CAA record or Certificate Authority Authorization record in their DNS. This record is used to limit which CAs can issue a SSL certificate for a given domain. If you want to verify this for your domain, you can use a dig command, like in this example that we have shown. Make sure that a CAA record for GGCert is available if you want to use the Azure Front Door Manage certificates. Once this is done, you simply add an Azure Front Door rule that forwards the traffic coming into the custom domain to your backend. Let's look at a demo of this in action. With that, we are at the end of our session. Here are some resources for your consumption to learn about Microsoft Identity Platform. We thank you for joining us today.